So thank you and welcome. This is the Center for Sustainable Business's first strategy primer of the year. So this one's about building a circular economy with circular manufacturing. I am Lou Tierno. I am the Decarbonize Middle America Program Manager at the CSB. Really excited to be putting this on. I do tons of events like this and lots of programming as well. So please feel free to put your name and your information in the chat so we can connect afterwards and start networking. On to the next. So here's a little bit of an agenda for today. I'm going to give a little land acknowledgement from Pitt, and I have another slide about how you can get involved with the CSB. Then I'll hand it over to Patty for introductions, and we'll hear from our speakers. And then at the end, we'll have about 10 to 15 minutes for questions. Okay, so while we are virtual today, apropos to the topic of our conversation about an economy of makers where nothing is wasted, I wanted to pause and reflect on an example of some of the rich culture of the region that we can look to for lessons for today's conversation. Long before there was a city of Pittsburgh or the University of Pittsburgh, our region was populated by indigenous people. We are acknowledging that the land our community occupies was once home to the Adena culture, the Hopewell culture, and the Monongahela peoples, along with others. The history of our region documents that these communities established a presence representing the oldest recorded civilization in North America. They built thriving societies that lasted for generations. By becoming aware of and respecting the history of indigenous people in the US and around the globe, people can learn to not repeat what has happened in the past while working towards a future in which we respect, revere, and live in harmony with the people who were here first, as well as the future generations we are borrowing the land from. And so I just wanted to give a little bit of information about what's going on at the CSB and how you all can get involved going forward. And I have some people posting in the chat the links to these things. So our first public convening of Middle America will be on March 9th from 3 to 4 p.m. A similar format to this, but a little bit more conversational, just asking questions about what we want to see in Middle America, which is Appalachia and the Ohio River Valley. You can join our quarterly newsletter, which will have information about what's going on at the CSB, and the link to that will be in the chat as well. You can also engage us on all of our social media. It's at Pitt CSB on LinkedIn, Instagram, you name it. It's the same everywhere. There's also, we'll put a link in the chat for our podcast, which is uploaded to YouTube and all other podcast channels for listening to that. And we actually have a new LinkedIn group as well. And so we'll be promoting that as a kind of just a general place for people that show up to these events who are interested in the work that the CSB is doing to join and connect and be able to share what they're doing and the work that they're working on. I also wanted to promote Pitt Day of Giving. We have two, I think, links that we've kind of set aside for you all for Pitt Business and also from the Office of Sustainability. And so those will be helping out the respective parties there. And more information will be on those links. And so I wanted to pass it on over to Patty. You can start sharing your screen and take it away.
Well, hello, everyone. I am delighted to be here and have a chance to share a few ideas framing our discussion for today. I wanted to start with, first of all, just the concept of what a circular economy might mean for us and why this matters. I don't know if you heard the President's State of the Union address a few weeks ago, but when he was talking about Buy American, and he talked about this several times and about rebuilding a manufacturing base. Well, there are some implications if we actually do that. There are some serious practical logistical implications as well as policy implications. I think the reality is that if we continue our business as usual, we are going to be requiring many, many more resources than the Earth can support, and we will not be able to address our climate goals. And this is the goals set by having 1.5 degree range of increase in our temperature overall from the pre-industrial time. we are not on track to get anywhere close. So we need a policy U-turn to have this happen. And one of the major policy U-turns is really in the way we handle manufacturing, the way we handle materials. We need to move to renewable energy resource systems instead of just fuel switching. We need to have regenerative food production systems that restore the land and sequester carbon. And we need to look at circular materials management by design, meeting the needs of community and building a sustainable future. So what this entails is recognizing that we have a very wasteful economy. We are the second most wasteful industrialized country in the world. And we have regulations and economic instruments that seek to prevent or mitigate certain impacts, but rarely take meaningful action in the upstream or downstream supply chain. We do not have a policy that recognizes the materials come from somewhere and they go somewhere. It's all about the transaction where you use the product and pay for it and generate taxes and revenue. So most of the, like if you take plastic as an example, only 0.1% is continuously recycled, and a very small amount is continuing in use from its production in the 50s. Most of it is wasted straight into a landfill or discarded. This is just one example of the very wasteful system that we have established here, going from raw material extraction, manufacture, consumption, and then to a landfill. And what we have is a drawdown of the fossil reserves from beneath the Earth's surface. It places high value on the production and consumption. There is no negative salvage value. There is minimum recycling of minerals in our country. And this is not a pathway that we can sustain, especially if we're going to be doing manufacturing and made in America as a policy. So we need to look at taking minimum raw materials from the crust of the earth for manufacturing and consuming, and then reuse, repair, recycle, and return back to the production system. This entire section here is missing from our economic incentive system. We have an opportunity to build not only jobs, but also entire new industries where we design to manufacture things and consume things for reuse. We design for consumer value and quality instead of quantity and once used and thrown away. This is an opportunity for a cultural shift that will replace fossil raw materials with biological materials, that we can use regenerative agriculture for fibers, silviculture, permaculture, algae farm products as feedstocks instead of fossil feedstocks. Design for material reclamation, repurposing, or reuse, and returning our wastes to a biological cycle rather than to a landfill where they become, toxic and hazardous burdens. So we need to begin to create this flow and start thinking of our production system more like an ecosystem where there is nothing wasted. Nature does not waste. Everything becomes the input for something else. I don't know where everything went right now. And what we need to do is now begin to look at how this is going on now and then move forward. So we're going to hear from Epic Metals, where they've been using and reclaiming material. We're going to hear from packaging issues from John Holmes. We're going to hear from Steve Laich from batteries and from Joanne Martin. And I would like to stop sharing now and give the podium over to David Landis from Epic Metals. He is the president of Epic Metals. They have been in business for 55 years, using mostly recycled steel and using a tremendous amount of sustainability initiatives in his production system. David, the floor is yours.
Thank you, Patty, and thank you also, Lou, for having me. I assume everybody can hear me well, and I'll just take you through a brief presentation about some of the things that we've been doing. Epic Metals has been a member of the U.S. Green Building Council since 2004, and the steel panels that we manufacture are used for commercial construction, and they typically have a recycled steel content of between 25 and 61%. And the acoustical element, that what you see in yellow for absorbing sound, typically has a 30% recycled content. And then by putting paints, finished painting on the systems, we can reduce up to 97% of the HAPs and VOCs by doing that in a factory as compared to in the field. There are two processes, for making steel. One is the basic oxygen furnace that is typically using 20 to 35% recycled steel. And the other is the electric arc furnace process that's using about 72% recycled steel. So all steel made in the United States has some percentage of recycled content. Today in the United States, we're recycling the equivalent of approximately 14 million cars a year, so that in essence, all the new cars, the steel that's used in them is coming from recycling old cars. Epic Metals has to date supplied our panels to 352 LEED certified projects in 41 states. Of those, 27 have had the highest LEED rating of a platinum, and 156 have been LEED certified gold. And then we have the balance are either silver certified or just LEED certified. And this is a map of the United States of our 352 LEED certified projects that we've participated in. Our manufacturing facility in Bartow, Florida has ground-mounted solar panels. We mounted them on the ground because of the hurricanes that are in Florida. And through May of 2022, we've generated 814,850 kilowatt hours of solar energy. And, through May of 2022, we'd operated this facility for 58 months without using any energy from the grid, just by using solar energy. Now we're up to 64 months. At our eco-friendly home office in the suburbs of Pittsburgh, we have solar panels on the roof, and we also heat and cool the building predominantly with a geothermal system where we have wells that are drilled down into the earth. We also have a solar parking canopy that we use to generate solar energy, and to date, that canopy has generated 155,000 kilowatt hours of electricity. Underneath the canopy and at another facility that Epic has, we have 11 electric vehicle charging stations. And through May, we had displaced the burning of 12,509 gallons of gasoline. Now we're up to, as of January, over 16,500 gallons of gasoline that we've displaced the burning of. And to give you a reference point as to what that amount of fuel is, basically the tractor trailer that fills up your gasoline station can carry about 11,600 gallons of gasoline. We have another manufacturing location in Greensburg, Pennsylvania, where we have over 1,000 solar panels on the roof. And through May of 2022, we generated over 1,470,000 kilowatt hours of solar energy. We're powering that facility about 60% from the sun. At a facility that we have along the Monongahela River, the river valley provides a natural place to generate wind energy, and we have 3 vertical axis wind turbines that we're using to generate the electricity for the lighting of the building that you can see behind the 3 vertical axis wind turbines. At a manufacturing facility we have in Rankin, Pennsylvania, we have solar panels on 2 additions that have generated over 206,000 kilowatt hours of solar energy. at that facility, we also installed pervious pavers to reduce the stormwater runoff. And this is a chart that shows the amount of solar energy. When we started, our first project was in 2010, and we generated a massive 271 kilowatts of solar energy. And now in actually this table only shows up to 2021, but if we added the bar for 2022, we'd actually see an increase of 8%. So again, over 500,000 kilowatt hours of solar energy we're generating per year. Using the globe as an example, we've generated enough solar energy to power an electric vehicle to go 235 times around the globe. And one of my favorite people that I like to quote is Lester Brown, and he published a book called The Great Transition. In that book, he states that the sunlight striking the Earth's surface in just 1 hour delivers enough energy to power the world economy for 1 year. And one of the systems that we manufacture, we call Taurus. It's a roof and floor deck ceiling system. And these are some of those panels that we manufacture. And some of the pictures of projects that we've done. We did a project out in Colorado Springs, the Bow Seal Engineering, that has our panels on this barrel vault roof. This Shawnee Mission School Aquatic Center in Lenexus, Kansas has our panels. One of the unique things that we do is we can cut our panels and reinforce them to use solar tubes, which is a tubular skylight into our panels. And we've done a number of projects that have used those systems. That Bow Seal Engineering project that I showed you the earlier picture of, in their manufacturing location, they used over 500 of these solar tubes to bring natural light into the facility to reduce the electric demand. This is a project in Springfield, Missouri, that again used our tubular skylights to enhance the lighting of the pool. Another one of our product lines is Wide Deck, and it was installed at the Cornell University's Bill and Melinda Gates Hall project. It was a LEED Gold certified project, and there you can see our panels on the ceiling, and they provide the floor deck. In the Pittsburgh area, we provided our panels for the Carnegie Museum of Natural History Dinosaur Hall. They moved the dinosaurs to what used to be a courtyard. They enclosed the courtyard and used our panels as the ceiling of that structure. At the Half Moon Bay Library in Half Moon Bay, California, that's a LEED Platinum certified project. Our panels were used as the structural roof deck ceiling system. At the Ford Center in Evansville, Indiana, a LEED Silver certified project, our panels provide the wall and the roof deck ceiling system. Moving on to another system, our Invista panels. Shows a variety of those panels, again, used in commercial construction. One project that we did was the Austin Bergstrom International Airport Terminal in Austin, Texas, a LEED Gold certified project, and those are our panels that are providing the roof deck ceiling system of that project. And this is an Invista Specular A panel that was used on the Dickies Arena, similar in size to the Pittsburgh PPG Arena. And those are our panels providing the roof deck ceiling system for that project. Moving on to architectural and sunscreen panels, we do manufacture some panels that are used to reduce the heat gain from the sun. And this was a project in Davis, California, the university. And the next image shows how transparent the panels are. I don't know how well the video shows up, but it's blocking about 50% of the heat energy from entering the building. And at this Carnegie Library and outside of Pittsburgh and Carrick, they sunscreens were used to create like an eyebrow above the windows to reduce the heat gain. We've been a manufacturer based outside of Pittsburgh, Pennsylvania. We're going into our 55th year in April, but to date, it's 54 years. That's the end of my presentation.
Thank you so much, David. Thank you. That was really interesting. And now we're gonna hold questions until the end. Is that right, Lou? So I will hear now from John Holm of Pixera Global. He is Vice President of Strategic Initiatives, and he's going to talk about some logistics and reverse logistics. And John, the floor is yours.
Yeah, hi, thank you. Thank you so much for having me, and everyone. It's good to virtually see you, at least on the chat. I see you're acting up. So happy Monday. A little bit of context about the organization and why we're here. We're a 501c3, and I think what's unique about that is we work at the intersection of public, private, and social sectors to solve what we call solvable problems. And we do that really lock in step, representing communities around the world. A lot of our work, we got into circular about 4 years ago. And I think what's unique about our approach is that we looked at the circular economy transition in the space, not as recycling and not as sustainable packaging. That really is not what we're talking about at this stage. So I want to go back to what Patty said earlier. We're talking about systems change, a transition to a just and equitable transition to a reduce, reuse, repurpose environment where we're maximizing the resources that we have on this planet and staying within the planetary boundaries of which we need to live in for the world to thrive and survive. And so in that context, we do this usually in partnership. We're never really alone. And in that context, we work with organizations that Pittsburghians, First Mile, Metabolic, NL, FedEx, Circular Cleveland. You'll see a broad swath of public, private, and social here. So a little bit of context of what I'm going to talk about today. One, I'm going to focus a little bit on a very specific piece of manufacturing we call remanufacturing around this idea for the need for reverse logistics. And thinking through how Pittsburgh's really set really well to really own that conversation, not to be a manufacturing hub, but to be a remanufacturing hub. Then two, we're going to talk a little bit about systems change from a city level. I'm going to share with you a little bit about the Circular City Coalition. If you're interested, go to circularcitycoalition.com or just hang tight and we'll share a little bit with you of what we're trying to accomplish with cities at the nexus of policy and business and humanity as we move forward. So let's dive right in. Before we jump in, I want to tackle this point of circular economy. I mean, this is a very North American-centric view, is that circular economy is usually antiquated, and it is antiquated, so connected with recycling. Recycling is last on the value hill. So when you look at waste, it's the last piece before we get in there. Patty said earlier, design out waste. And I think what we need right now is a revolution to think through the design process, not just the design process from when you make a product, what materials you're extracting, what you're making, but also not designing a product to break down, planned obsolescence, really designing it to break down, go back to the environment, to continue making more of it again. This is not working anymore. We're seeing this with our climate. We're seeing this with big spills in Ohio. We're seeing this on the shores in Ghana. We are just not doing well with conserving our resources. And so when you think of the circular economy, I want you to take away a couple of things here as we move forward. When you hear the word circular economy, I want you to go home today and think about what that means to you. What does that definition mean to you? The answer is broad. Before Ellen MacArthur Foundation really brought this term back into the space in about 2010, this idea of reusing, reducing, and repurposing parts has been around forever. And so think about it personally on these three questions. Think about when was the last time you went to get your shoes repaired? Think about when was the last time you needed to barter for clothing or furniture, or think about when was the last time you had to grow your own food because the closest grocery store was 2 miles away. Most of the people, I would say the majority of people living in the world today do not have the luxury of buying stuff and throwing it out. Yeah. That much of the resources we have, humanity is using stuff. It's just the subset of people which control the wealth, which throw stuff away. Waste is a privilege, and I want to get that through with you today when you look at some of the work we're doing of how we can retool our thinking, our behaviors, our mindsets to be more mindful of reduce, reuse, repurpose. So when you're driving some of those communities and you see Patagonia come out with a reuse workshop, repair your jacket. This is a great thing. Buy our jacket for $500 and you can repair it. Note that many people in the world, and probably in the communities you live in, have to repair their shoes because they can't just go buy another pair. So framing a little bit of how we think about circular. And so on that note, let's dive in. What you see here is through the mind of the private sector. And I think it's really important to jump into the mind of the private sector of how we can think through circular economy in that space, because they control the money, they control the assets. So where's the proposition of how we can define a profitable value proposition around this term circular economy in a way that stays within the planetary boundaries? And so what you're seeing here is actually reference from the Circular Economy Handbook written by Accenture, but it's a really good handbook that really provides context of a way of thinking through the circular business models that are available, thinking through how private sector is thinking of this transformation, and really thinking through a circular value circle, not a circular value chain, a circle where you design out waste from inception, starting at design, and you're ending through reverse logistics. It's not ending with the end of life. You're thinking through then this concept of reverse logistics. And so what is this thing of reverse logistics that I've now said 3 times? Well, before I tell you what that is, let's give you the problem that's facing humanity right now. And we'll go with the United States. I mentioned to you earlier this concept of making things to make it break down. The average user, an average American, this is fact, with fast fashion, buys a piece of clothing and wears it 7 times before discarding it. That's fast fashion. So when you hear sustainable fashion, it's kind of an oxymoron of how it's designed. Here's some of the mechanisms about this. You know, we hit COVID, started buying stuff online, click and buy, click and buy, click and buy. Well, when COVID really started hitting, we saw product returns surge 78% to $761 billion between just 2020 and 2021 alone. 16.6% of all retail sales were sent back compared just to 10.6% earlier. So furthering that explosion of people just buying stuff online and just trying to send it back, what's frustrating when you look at the fashion industry, and I hate to pick on fashion because they're not the only ones that are guilty, but there's a lot of publicity around it. In 2018, Burberry announced it would stop burning unsold goods after it was found to have destroyed clothes and perfume worth over $36 million the previous year. And in December 2021, Coach admitted to damaging unsold bags, which is not really a new practice. I say that because we got to think through consumption the way we look at things again. Think through a little bit of the business models behind it. And the thing with Burberry and Coach I want you to think through is, number one, what policy stopped them from doing that? Is there any policy that stops them from doing that? 2, where's the business value in those materials that they destroyed? I'm sure that cotton, that water is worth something. How's it being valued? How's it being taken care of? Is it being valued? No. So maybe when you start thinking of policy, start thinking through the materials we're extracting and what policies can work to help preserve them. And so now let's talk about what reverse logistics is. Everybody knows about the supply chain. You know, you extract, you procure, you make the product, you turn it into something, then you go through the sales process. That's great. What everyone also knows, though, is that it cannot end there, right? Like, so it cannot just be there. So what about that process after you do that of retrieving the product or the material, transport of that product of the material, inspect the product, sort it, and then turn it into something, whether you're reselling it, reusing it, remanufacturing, repairing it, refurbishing it. The good news is that this trend is now coming alive, and we're able to participate in seeing this trend come to action. The bad news is that companies that are doing this, the Apples that really well, the Apples, the Ciscos, the Dells, they're all about high value material, which have a lot of value, and there's a lot of investment going to that, but it's not shared. It's not like there's a warehouse. It's controlled on the IP itself. So when you look at this reverse logistics process, then think through a little bit, then when a company, what do they have in line that one, how much is the material they make something valuable? Is it valuable? Is that material worth it? Or is it easier or cheaper to make something new, like new resin and plastic, than it is to actually recycle it? Because as what Patty said earlier, recycling in plastic really doesn't happen. It's very limited. Actually, 5% of all 1s and 2s actually recycled in the United States per the report by Greenpeace most recently. So when you're thinking through material, think through, can it be recycled? Can it be reused? Can it be reduced? But think through that from a value chain aspect. And then also with the material itself, can we get economies of scale of taking material, bringing it to a hub, and then having it sorted effectively and efficiently and scaling that out? So again, if you look at hubs in areas like Pittsburgh, we mentioned steel earlier. We look at areas like Cleveland, Ohio, which are logistic hubs. You're seeing now an idea come to mind of what we become like a reverse logistics hub. We're imagining the FedExes and the Amazons and the UPS take material together, come to an area and then remanufacture it or convert it into something else. So this is a trend that's starting to take place. You're seeing companies now getting out there in the space. And I want to end on a good note here, just on this reverse logistics high. Technology is key. SAP, Microsoft are on the back end of looking at tracking this waste and looking at investing in how we can find solutions around reverse logistics. It's commoditized value. So money, material with higher value can be remanufactured. So when you're looking at organic material such as wood, or material like rare earth minerals, that will be reduced, procured, and taken back. Leaders, again, tech industry in the space, Dell, Cisco, Apple are doing great job. And then, yes, fashion has a lot of catching up to do, just because of what the material of the fabric is, and really trying to procure that and get scale on that. So a couple things to think through when you're looking at reverse logistics, but it's a great opportunity and something for the city of Pittsburgh to actually explore further around key industry areas that Pittsburgh operates, such as steel. Now, that was a systems approach, a quick deep dive, and happy to talk with you folks online of what this looks like and more deeper on the reverse logistics side. So systems around logistics to reverse logistics, systems around manufacturing to remanufacturing, and trying to create business creation and value out of it while incentivizing that. The next piece here is like, how do you look at cities though, right? So let's take it a step further. We know now that the Earth is not really doing well with its 1.5 degree promise. As Patty highlighted earlier, showed a lot of stats. Essentially, we're warming up. We're feeling that right now. We're coming to this nexus of decarbonization, which we really got to move forward to rapidly decarbonize the world. We got to move off oil and gas. We got to really make that transition to renewable energy, but also really got to start looking at our food systems more. We start out looking at the built environment of which we're building materials and building buildings now. How do we actually create change at scale across cities to take policy and use it as an enforcer to upstream regenerative business practices that can decarbonize the world? When you see the Inflation Reduction Act by Biden, there's some beauty in there. Actually, for Middle America and Appalachia, there's some beauty of translating a lot of the work on building new infrastructure for this type of work that we need to move forward. But it's critical with the cities that we're working in to think through this decarbonization and equality nexus. And so this is what the Circular City Coalition is about, is looking at the nexus of decarbonization and equality with circularity as the byline. And so this group here right now is consisting of NL, Climate Kick, which is based in the EU and does all the EU grant making. NL is the largest renewable energy company in the world. Pixar Global Us, Metabolic, which does a lot of circular design for cities on policies and implementation in the European Union. Reaply, which is a really great technology on reuse, which is scaling across the United States. And then last, but definitely not least, First Mile. First Mile, which is kind of the soul of the group and really understands representation of the bottom of the pyramid up and taking ownership of these things. So what you see here is just some numbers. These numbers are important, though, represent the decarbonization platform that all these companies or these organizations exist. And what we're in the process of doing is going to market right now to fundraise to select 5 to 7 cities of which we're going to bring our model to in the United States first, and then hopefully the world. And when we look at what that model looks like, it's really trying to think through both top down and then bottom up. When we say by top down is thinking through how does the decarbonization around renewable energy, recycling, renewable energy, built environment, and agriculture, how does that look from a policy engagement piece, from an ultra high net worth investment space, corporate space, and create a platform for all those investments to land on, with the city, for the investments that come in, having to put the necessary policy procurement packages in place to enable it, while simultaneously we're working with the federal government, IRA, to build funding platforms to bring that in. While we're doing that top down, bottom up, and this is kind of the key. I mentioned to you earlier, reduce, reuse, repurpose. These skill sets, which generally in the United States exist in historically marginalized communities, we want to bring those skill sets up and make those the primary investor centers. So those nerves where the poorest are, where the most impacted are by pollution, those are the first places of investment for decarbonization. So in decarbonization investments mean microgrid applications. It means capacity building training on vocational training for renewable energy food. and for built environment. It's creating startups around those three areas at scale and bringing back small businesses instead of just sitting there waiting for big oligopolies to buy another company and hamstringing the relationships that we have with being an entrepreneur. So we're in the process of doing this now. Pittsburgh is on the list of one of the cities that we're working with because of the great work that you're already doing in the space. And we just want to light that fire and continue on working with you as we move forward. So the goal of us at the end of the day is really to look to have 30 US cities decarbonize and transform into regenerative and equitable economic hubs, targeting 25% of US emissions. We want to unlock billions of dollars of co-investment dollars in the cities we select and further. And we want to create a grassroots movement where everyone wants to participate in this model moving forward and unleash and unlock so much policy and procurement activity that links specifically in equality, climate justice, decarbonization, and business. This is not activism. This is just the changing of a new mechanism of how we have to move forward. So there you go. There's me. Nice talking to everyone today. Any questions, please reach out. My contact information can be there. And I'm passing it on.
Wow. I have so much to think about in that.
Patty, we've lost your audio.
Thank you. Well, that was a lot to think about and very exciting. And I think we're going to have a lot to talk about. So I want to get to our next presentation from Steve Laich, who is the Director of Operations for EOS Energy, which is a battery manufacturer in Turtle Creek, doing really exciting stuff with non-toxic earth elements. Thank you, Steve. The floor is yours.
Hello, yes. So EOS,
You're here. We can see that.
okay. EOS is producing a non-lithium based battery. There's a lot of competition to produce non-lithium batteries for many, many reasons. I mean, lithium is a rare earth element. It's mined primarily in third world countries. It's very flammable. It's very toxic. It's very explosive. So EOS was formed in 2008. We are headquartered in Edison, New Jersey, but we manufacture everything in Turtle Creek, Pennsylvania. Our leadership has over 200 years experience in the energy industries. We now produced a battery and brought to market a battery that's based in zinc bromide. Now, zinc bromide happens to be the same thing that people used to frack with. It's a very common material. It's available all over the world, and it's classified through the EPA as a Class 9 hazard. That means it's toxic to fish in massive quantities. It's not a corrosive. It's not flammable. It's 40% aqueous. And our batteries that we put together, we believe, have about a 20-year life expectancy, which is very unusual compared to a lithium battery. Here's our technology. So we take zinc bromium in water, and we put it into a closed cell sealed battery. And when we introduce energy, the zinc and the bromium, they separate, and the zinc will collect on the anode, and the bromium will get absorbed by the cathode. When you reverse that reaction, you will generate electricity and a little bit of heat. We've perfected our chemistry so that we don't have dendrite buildup, which has always been a big problem with these kinds of batteries. And we see no degradation in our batteries' performance over a span of 20 years, despite the cycles. So we take these individual batteries and we put them into something that we call an energy block. We package these things in 500 kilowatt containers so that they can be used in front of the meter to collect power at energy generating businesses. It could be any kind of energy generating source. It could be solar, it could be wind, it could also be conventional energy. We have a battery management system that controls the battery. These individual batteries are stacked in both series and parallel rows and controlled. We measure temperature and we measure state of charge. And it's very simple. We've already integrated these things with standard equipment for inverters and converters and management systems. So it's a very robust and easily applied technology. Our batteries, again, have a 20-year life expectancy. That's based on the plastic that we use. We're using high-density polyethylene, HDPE, a very common plastic that's very recyclable. We believe that the plasticizer in that plastic will get exhausted after about 20 years, and the batteries become brittle and may start to leak. We've already demonstrated that we can operate in a very wide range of temperatures. It will not freeze at below 20 Celsius. And we will show you a case study here in India where we were operating in temperatures in excess of 50 degrees Celsius without any degradation of performance. Also, very unique to our battery compared to lithium is we have a very, very flexible life cycle. We can discharge anywhere between 4 and 12 hours. Now, lithium will like to discharge in 1 to 3 hours. And that makes it also, it's a very powerful discharge, make it perfect for energizing an electric car. Our battery would never make it an electric car. It's more designed for solar fields and for wind. It's going to gradually discharge and really be exhausted in about 12 hours. Now, another unique thing about the battery, it's a chemistry set, right? We're going to take zinc and bromine, we're going to separate, and we're going to put it back together. So we don't care whether or not you discharge to 0% or charge to 100% or anything in between. As a matter of fact, these batteries could go to 0 and be stored for 3 years and then put in service, and there'll be, again, no degradation of performance. Everything in that battery is recyclable. The zinc and the bromine, they're very desired in a lot of industries. The HBT, the high density polyethylene is very recyclable. In our Gen 2.3 battery, the cathode is grade 1 titanium, very easily recycled and recovered. In our next generation battery, though, we're not going to use titanium. We're going to be using a conductive biopolymer that is also HDPE and can be recycled through the same channels. Here's a real-life example where a battery system was discharged in 12 hours, and 6 hours, and 4 hours, and even as little as 3 hours with no degradation in performance. It's the same consistent flatline performance, the constant voltage, and very little thermal variation too. This is important because you see a lot of different case studies in the world. People want to do microgrids, and some people they like Enel. Enel is a big customer of ours, and they have a system where they need to guarantee that they always have so much kilowatt hour energy in reserve. So they're going to actually keep our batteries topped off to a certain degree, and they may only discharge 80% and go back to 100. That's perfectly fine for our batteries, and it will not degrade the performance. Here's an example in South Carolina. They have purchased 80 megawatt hours of energy. They've got a solar field and an old peanut farm. And our containers have been deployed in 500 kilowatt hour energy blocks. They have 184 of them. They'll collect the energy when the sun shines, and they'll discharge when it's dark. Overall, in the world, we've already deployed almost 800 megawatt hours of energy. Now, this is a race, and the IRA, the Inflation Reduction Act, has caused a lot of impetus for a lot of companies to start up and provide a battery that's not lithium based. Right now, to date, we're the only ones that have actually manufactured and deployed batteries to customers. There may be a better technology out there, but right now, we are really the only alternative to lithium that you can actually physically handle and buy. We had a pilot project in India where we gave them 7 energy blocks, 3.5 megawatt hours of energy through a single inverter. Through last year, they saw ambient temperatures that exceeded 45 degrees Celsius, and our batteries saw 55 degrees Celsius. Also, they suffered the worst sandstorm in 100 years. They sent us a video where they opened the doors of our containers, and these energy blocks are basically shipping containers. In fact, many of them came from Seabox. They opened the doors, and 3 feet of sand fell out of these containers, yet the energy block continued to perform. So very robust and rugged technology that can survive in very hostile environments. Another example, and this is probably one area where we think we've got a lot of improvement to do. If you look at this is a typical multi-cycle, multi-day cycling of some batteries. This is a real test case. Our round trip efficiency was about 74%. Now that's not as good as lithium. Lithium is probably 5 to 10% better than our batteries today. We continue to work to try to close that gap. And I think in our next generation battery, which I will show you in just a moment, we've closed the gap quite a bit. So here's Turtle Creek, today manufacturing the Gen 2.3 battery. The battery that you see down here in the bottom, it's about 14 by 14 inches, almost 2 feet long. And when it's filled with electrolyte, weighs about 245 pounds. What we do is we weld these individual frames together with the bipolar inside the battery, and it's a titanium, grade 1 titanium sheet. It has a special carburized process to help drive carbon into the surface so that it has a way to precipitate the zinc onto the plate. And on the backside is just pan felt. Pan felt's available all over the world. However, all sources come from China. It is a concern of ours. We've asked the federal government to look at helping us to fund companies in the United States to make pan felt. We also take that pan felt, impregnate that with carbon to help the bromium absorb into the felt. Now, that is a very difficult battery to manufacture. There's 42 infrared welds that happen around the perimeter of that battery to put it together. And that's 42 potential leak points for that battery. However, 144 of those go into our container, make the strings, 12 strings of 12 batteries that equal about 500 kilowatt hours of energy. The next battery, though, and we have already begun to manufacture it upstairs, looks a lot more like a conventional automotive lead acid battery. It's a tub. And in that tub, we insert these bipolars. Now we're only 20 cells instead of 42 cells. This battery, when we weld the lid on, weighs about 45 pounds. We expect to expand our operation so that we can be doing 3 gigawatt hours of energy per year in this plant in Turtle Creek by 2025. This battery also opens up for us a lot of new markets. Now we can think about going in front of the meter or behind the meter instead of in front of the meter. So here's a battery module. You can see the bipolar slide down into the tub. We fill it with our electrolyte, and then we do a simple vibration weld to cause friction. Takes about 7 seconds to weld the lid on top of that battery. The failure points have been reduced 100-fold. Those batteries can then be packed very tightly into an energy cube. So instead of using a 20-foot shipping container, we now have a cube that we can pack. It's half the footprint, and our energy density has increased dramatically, improving the efficiency too. Those cubes can then be stacked. Show an example here. We've got 5 in a row. That's about 40-foot shipping container. We can do more, we can do less. We have a lot more flexibility. And now suddenly we can think about maybe energizing things like solar panels for an EV charging station, or maybe even in a subdivision, or maybe even in your homes, where you can take advantage of putting energy into your batteries when the peak power is less expensive, and then feeding off the battery when it's more expensive. It opens up a lot of possibilities for us. So we're very excited about this opportunity. The Inflation Reduction Act is causing a lot of activities in this particular market sector. Certainly our zinc bromium battery, it's available today. You can buy it now, and we have many inquiries, well over $6 billion worth of inquiries into our orders right now, and that's only going to increase. But it's also going to generate and stimulate a lot of competition. That's good. We don't think EOS is the only solution. We think it's part of a bigger, broad spectrum of solutions for energy storage. We also think that the IRA is going to create a lot of impetus for customers to demand these kinds of products. Our battery currently is almost 95% domestically sourced. The only thing about our battery that's not available domestically is the pan felt. Most of our products for our batteries are within a 5-hour driving distance of the city of Pittsburgh. But that could be true of any city. None of these products, the HBDE, the titanium, the zinc bromide, they're available all over the world, making this a very flexible battery to start up with. If we would build a lithium plant, that would generate a gigawatt per hour of energy. You're probably talking about a $250 million investment and about 2.5 years to build, especially with the clean rooms and the permitting that's going to be required. With our battery using just available elements around the world, we think that we could generate the same size of a plant with about $50 million in investment and about 6 to 8 months of time to put that building up. So if we have a big order in Australia, we could build the plant in Australia rather than ship them from Turtle Creek. So everything about this battery is recyclable. We do think it's got a 20-year life expectancy. It's going to be a long time before we need to recycle those things. The new battery, the Gen 3 battery with the lid on top, gives me a great opportunity to rework batteries and reduce scrap and make it 6 Sigma. So there'll be a little waste. Most of the things that we need to manufacture this battery with are very low tech. We can take people with GED or high school educations and put them into service in about 2 days. So it's a very exciting product, and we're very pleased with it.
Thank you. Sorry about that.
No problem.
Okay, so we're running over time a little bit. I want to give Joanne Martin a chance to talk about the Eco-Industrial Park. She is the Executive Director of ReImagine Beaver County and has been doing some wonderful work. We want to have time to hear from her. And Joanne, why don't you dive right into it?
Thank you, Patty. I'll talk fast, and I'm honored to back cleanup on this brilliant panel today. I'm going to be bringing in the grassroots voice of how community visioning is central to circular manufacturing, designing a system. So design is key to a circular system, and the 4 stages of the system listed on the Ellen MacArthur website: understand, define, make, and release. These all rely upon community involvement. Maybe less tangible, no less important than the community involvement, it brings a sense of ownership, destiny, and empowerment to these projects. I'll also interject another less tangible element of circularity that maybe isn't so discussed. A circle's a symbol of wholeness and unity, and it's a pattern that eliminates hierarchy. So if you imagine a group of people sitting in a circle, no one is superior. And then let me also add, the design element goes beyond human-centered. What really is called for is a true ecological approach that involves human and otherwise non-humans. So this ReImagine project is a start towards deep community involvement in systems. It began in 2017 with a goal to mobilize green tech development. And this push was largely in response to the petrochemical hub that's taken over this region. Residents saw an urgent need for a new economic paradigm that prioritized public health, created family-sustaining jobs, protects the environment, and addresses climate change in a robust way. These stakeholders came together and agreed upon a couple core values. One big one: want to do the right thing, we have to stop doing the wrong thing. And for this group of people, this means moving away from the fossil fuel industries, continue to make harmful plastics, and rely on back-end recycling solutions, as you've all alluded to, is a dangerous model to perpetuate. So the visioning session started by identifying what kind of sustainable businesses folks wanted. This highlights an important part of working in communities. You start where the communities are, where their concerns are, and you move at their pacing. This is part of a circular design, all about mutuality and interdependency. And this whole involvement, there's going to be a link put in for a video, shows these interactive sessions where people jumped in with ideas, and we've captured all of that work as we've gone forward to design this future project. People kept asking, and this process asks a lot of questions. Again, circling back, circular. You know, you go back and you test your assumptions, you try on new ideas, you adjust, circle back. Yeah, it's an iterative process. It's repetitive. It's a slow is fast process, which maybe is a little cumbersome for some of the more familiar business models. But But so all this visioning work led to some things very concrete. There were 4 sectors of growth I initially identified. And over time, as this group continued to work together, they focused in on a single project in the green chemistry sector to look towards building an eco-industrial park. And again, this is guided by a vision to replace the petrochemical industry dominance in the region. Our research started to show there's much potential in considering biomaterials, and this ReImagine team is considering this eco-industrial park as a way to build that out. So the traditional elements of eco parks parallel many of those for circular design. Key ones involve the local people, look at the local geography and the local assets, and involve the community at the early stages of this paradigm changing economic development. That's where likely we're going to be led to success. So we've been working with a number of partners. One in particular I want to mention, ReImagine Appalachia, is a coalition of thousands of people, hundreds of organizations that have developed over the last few years, and they're working diligently to bring a lot of these ideas into the foreground. They're one of our key partners, as there are many. And just in wrapping up, there are many elements to circular design. We talked about a lot of the tech pieces of it today. You know, the 3 principles: eliminate waste and pollution, circulate products and materials, and regenerate nature, all really key. I know I've zeroed in on one. It's kind of an important one that's fundamental to all these principles. And that's really to involve the community from the start. I think John mentioned that, grassroots movement. It's business, not activism. Maybe a little activism kind of lights the fire on some folks, so that's okay. But there's much to learn from some of the co-op models that it's not all about earning money for investors. It's about quality of life for all. And I zipped through that really fast, sorry, but I wanted to leave space for questions. So I'll stop sharing, and hopefully we got some time there.
Well, thank you, Joanne. That was really an amazing summation of an awful lot of work that's been going on for several years. And I think we're not going to have a lot of time for interactive questions at this point because we're almost at 4 o'clock. But I do hope that you gathered the progression here from movement in the direction of circularity from not only long established businesses, but new businesses, new technologies, and people looking at old problems in new ways. And I think this is going to be a robust series that we can spend time probing different aspects of all of these issues as we go forward. We've had 54 people on with us today. I think that's a great start. And I thank you all for sharing part of your afternoon with us. And I share our thanks and gratitude to our speakers, David and John and Steve and Joanne. I'm sure we could spend a whole afternoon exploring these things in more depth, and I hope that we can make time at some point soon to do that. So Lou, thank you for pulling this together, and everyone else, thank you for coming to share your time with us and your expertise.
Yes, thank you all for coming. I will be sending up a follow-up email with the recording and questions and tons of other information. So all the links in the chat, everything like that. So I appreciate you coming, and feel free to stick around if you have any questions, but I know some of the panelists need to leave at 4. So thank you all for coming. Appreciate it.
Yeah, and maybe we can look at framing the next series around the regulatory infrastructure and the market incentives that are necessary to institutionalize this process so that it isn't a one-off and so that it isn't everybody fighting against the mainstream. We need to make this mainstream. And in order for that to happen, we need the markets for that 3/4 circle that isn't there yet. And I think that's what we need to work on. So hopefully we can frame that for the next set of discussions. And I look forward to seeing all of you again in the future.